You're floating in space. In front of you is a black hole, a tear in the fabric of reality itself. You know you shouldn't get closer, but something pulls you forward. Gravity, inescapable, relentless. In a few moments, you'll cross the event horizon, the point of no return. After that, not even light can escape. What happens next is one of the most terrifying, beautiful, and mind-bending journeys in the universe. Today, I'm going to take you step by step through what happens if you fall into a black hole. From the moment you cross the event horizon to the moment you reach the singularity, if you even make it that far. This is your final journey. Let's begin. I'm Stella Atlas, and I explore the most extreme, terrifying, and beautiful phenomena in the universe. In this video, you'll discover what you see as you approach the event horizon, why time slows down and eventually stops for you, what spaghettification really means, whether you'd survive long enough to see the singularity, and what might be waiting for you on the other side. This isn't just science. This is a journey to the edge of reality itself. Buckle up, let's fall. Let's start at the beginning. You're 1 million kilometers away from a supermassive black hole. Let's say it's the one at the center of our galaxy, Sagittarius A Star. It has a mass of about 4 million suns. And from this distance, it looks beautiful. The accretion disk is made of gas, dust, and debris spiraling into the black hole at nearly the speed of light. Friction heats it to millions of degrees. It's one of the brightest objects in the universe, but at the center, nothing. Just a perfect black sphere. That's the event horizon. From here, you can still escape. Your spaceship's engines could fire and you could fly away. But you don't. You decide to fall. So you turn off your engines and you begin to drift toward the event horizon. As you get closer, gravity gets stronger, much stronger. At 100,000 kilometers, you start to feel it. Your spaceship is being pulled faster and faster. You're now moving at thousands of kilometers per second, and you're accelerating. But here's where things get weird. Time starts to slow down. According to Einstein's theory of general relativity, the stronger the gravity, the slower time moves. From your perspective, time feels normal. But to someone watching from far away, you appear to move in slow motion. The closer you get to the event horizon, the slower you appear to move. From the outside, you never actually cross it. You just get slower and slower until you freeze at the edge. But from your perspective, you keep falling. At 10,000 kilometers, you notice something incredible. The stars behind you shift to red. The stars in front of you shift to blue. This is called the Doppler effect. Light behind you is stretched. Light ahead of you is compressed. Gravity is so strong that it bends light. You begin to see stars that are actually behind the black hole. They form a perfect ring of light around it. It's one of the most beautiful sights in the universe. But you don't have much time. You're about to cross the event horizon. This is it, the point of no return. No wall, no barrier, just a boundary you can't see. Once you cross, you can never go back, not because something is pulling you in, but because space itself is falling inward faster than light. Inside the event horizon, every direction leads inward. Forward is inward, backward is inward. Escape is impossible. You're trapped. Yet nothing feels different. You don't feel a shock, you don't see a flash. You just keep falling. Welcome to Spaghettification. Tidal forces stretch you like spaghetti. Gravity is stronger at your feet than at your head. That difference tears you apart. At first, it's uncomfortable. Then your bones stretch, your muscles tear, your blood vessels rupture. Eventually, you're no longer human, just a stream of matter falling toward the singularity. If you're feeling uneasy, that's good. But this only happens in small black holes. In supermassive ones, the experience is different. You might cross the event horizon without even noticing. But deeper inside, the stretching begins. No one survives the singularity. As you fall, time becomes distorted. Seconds for you, billions of years for the universe outside. If you could look back, you'd see the universe race forward. But you can't. You're alone, cut off.
What if I told you black holes can spin so fast they twist space itself? When a massive star dies, it doesn't always explode quietly. Sometimes its core collapses so violently that it punches a hole in space-time, creating a black hole. But here's what most people don't realize. Black holes aren't just dark vacuum cleaners in space. They can spin at nearly the speed of light. And when they spin, they drag space-time around with them, a phenomenon called frame dragging. This means if you got too close, space itself would start to rotate. Not just you, not your ship. Space. Some black holes also fire gigantic jets of energy that stretch for millions of light years, brighter than entire galaxies. And here's the strangest part. We've actually taken a picture of one. Not the black hole itself, but its shadow. A shadow cast by something that emits no light. Black holes don't just swallow matter. They warp reality. And we're only beginning to understand them.
Falling. Some theories suggest a firewall, a wall of energy that destroys anything crossing the horizon. If it's real, you'd be gone instantly, but no one knows the truth. Finally, you reach the singularity, a place of infinite density, infinite gravity, where physics breaks down. Black holes aren't eternal. They slowly evaporate, and when they disappear, the mystery remains. So what happens if you fall into a black hole? Time slows, you fall inward, and then uncertainty. Would you take the journey?